Have you ever felt that the sheer pace of innovation in AI and robotics just leaves you a little breathless?
Oh, absolutely.
One moment it's, a new smartphone feature, the next it's humanoid robots doing backflips. It's a lot.
It really is. And keeping track of what actually matters can be tough.
Exactly. It can get lost in the noise. Well, consider this deep dive your personal shortcut. We're looking at the biggest advancements from late August 2025 in AI and robotics. We've gone through a really comprehensive overview from Dr. Anthony Onoja at the University of Surrey, plus, well, a whole stack of other sources, and we've tried to distill it down for you. Our mission today: to unpack these breakthroughs, everything from new AI making your tech more intuitive to some genuinely astonishing humanoid robots, and explore what it all really means for you.
And it's such a remarkable time for this. The updates really cover a huge spectrum, don't they?
They really do.
I mean, from consumer software that's subtly changing how you use your phone, your computer,
Yeah.
all the way to these highly specialized robots pushing physical limits, and even, space applications. But the compelling thing is they're not really isolated. They're deeply interconnected. It's like this accelerating wave of intelligence and autonomy.
Okay, let's unpack this then. Starting with the AI updates, the software side, that are changing how we interact with things, making software more agentic.
Right, agentic.
Now, when we say agentic, we mean the AI isn't just taking a command, it's sort of understanding your goal and can, take proactive steps for you, multi-step actions.
Like anticipating what you need next.
Exactly. Google, for instance, has been incredibly busy. Their Pixel phones, getting over 20 new AI features. Things like magic cues for smart suggestions, even live call translation.
Which is huge for communication barriers.
Massive. But maybe even more significant, their search AI mode is getting these agentic capabilities for AI Ultra subscribers. So imagine not just getting a search result, but the AI actually, say, planning your trip or managing your calendar based on a broad request.
That's a real shift. And this term, agentic capabilities, it really does signal something new, doesn't it?
It feels like it.
For you, the user, it means the AI isn't just answering one question or doing one simple thing. It's tackling more complex, multi-step tasks without needing you to constantly prompt it. Think of it like having a digital assistant that anticipates your next few moves, not just reacting to the last one. It implies a much more proactive AI experience.
And it's not just Google either. Microsoft's making big moves,
Yeah.
especially with their new Copilot function baked right into Excel.
Oh yeah, the Excel integration, that's huge.
Imagine, you can generate analysis, summaries, data classifications just by typing Copilot in a cell. Our sources even highlighted that Microsoft has officially caught up with Google in delivering agentic spreadsheets. That's quite a statement.
It is. And the key thing there is the integration into a tool like Excel. So ubiquitous, so critical for business. This isn't just another chatbot somewhere else. It's embedding that intelligence right where millions work with data every day. It radically changes who can leverage powerful data insights. So how do you see this shifting, like the whole definition of digital productivity? Not just for data scientists, but for the average user.
Well, that's a great point. It feels like it's not just about speed anymore. It's empowering people who aren't data experts to get complex insights that, previously needed a specialist. It really democratizes access to data within an organization. It's a huge shift.
Definitely.
And speaking of moving fast, Alibaba has put out some really compelling stuff too. They've got Qwen Image Edit, an AI model where you can conversationally edit photos. Just tell it what you want. Fix the red eye, make the sky bluer.
No more fiddling with sliders.
Exactly. But maybe even more impactful is Coder. They're calling it an agentic coding platform. And get this, it's 100% free to use, currently in public preview.
Okay, free and agentic for coding. That's a potential game changer for accessibility.
Right.
Making that kind of advanced AI-powered development tool totally free.
Yeah.
It just opens the door for potentially everyone. I mean, what could this mean for, say, startups or solo developers, people trying to build something fast without a massive budget?
It massively lowers the barrier to entry, doesn't it? Faster prototyping, maybe automated debugging. It could really help people get ideas off the ground much quicker, even if they're not, coding wizards. It feels disruptive.
Truly.
Then there's Cohere. They launched Cohere Reasoning. It's a new reasoning model aimed squarely at enterprises. And it's making waves because it's apparently outperforming rivals like GPT-O's and DeepSeek R1 on really key benchmarks.
Which benchmark specifically?
Agentic tasks, deep research, and importantly, safety benchmarks. Plus, it's available via Hugging Face, which is great for accessibility.
Okay, safety is crucial for enterprise adoption.
Absolutely. And not to be left out, DeepSeek also launched v3.1, an updated hybrid reasoner. This new version promises to get to answers faster than the old one and shows stronger performance in tool use and those multi-step agent tasks again.
That multi-step capability keeps coming up.
It does, and it scored an impressive 66% on StudyE Bench. StudyE Bench is notoriously hard, testing real-world software engineering problems. That score is getting close to the state-of-the-art, even for the big closed models.
Right. So if we look at the bigger picture here, these advancements in reasoning and safety from Cohere, from DeepSeek, it underscores this critical move towards, well, more reliable AI, more sophisticated AI. For businesses especially, this hits right at those core concerns.
Yeah.
Accuracy, trust, can the AI handle complexity without, making stuff up or causing problems?
Yeah.
Exactly. So this kind of robust performance is key for driving adoption. What kind of really mission-critical processes do you think could finally move to AI now, beyond just, say, chatbots?
That increased reliability opens doors, doesn't it? Maybe things like automated legal document review or helping with medical diagnosis support, areas where you absolutely need precision and trust.
Right. Moving beyond just information fetching to actual dependable decision support.
Exactly. Okay, so shifting gears. All this AI brain power, what does it mean for the physical world? Let's look at the robots themselves. Some really astonishing hardware developments lately.
The physical embodiment, yes.
China's Unitree, they're already known for those quite impressive robot dogs, right?
Yeah. The quadrupeds.
They've teased their next big thing, a new humanoid robot. 180 centimeters tall, so about human height, with 31 joint degrees of freedom.
Okay, 31 degrees of freedom. Just to clarify for listeners, think of that as 31 distinct ways his body parts can move, bend, twist, rotate. It gives it incredible potential for agility, for range of motion, like us, really.
And it expands their bipedal portfolio, suggesting they're serious about general-purpose humanoids, though the launch timeline is still a bit unclear.
Still, a significant move from them.
Definitely. But then you have WI Robotics, a South Korean company. They unveiled Alex, also a general-purpose humanoid. What seems really interesting about Alex is its modular platform design and a real focus on manipulation. Highly dexterous hands.
Dexterity is key. How dexterous are we talking?
They boast 15 degrees of freedom just across the fingers and wrist. That's serious fine motor control potential. Oh, and it can lift over 30 kilograms.
Wow. Okay, so strong and potentially delicate. That's a tricky combination.
It really is.
And that focus on manipulation, those hide-off hands on Alex, that's critical. It brings up a point. What real-world problems does that kind of dexterity actually solve? Most industrial robots are great at repetitive stuff, right? Pick and place.
Yeah.
But grasping unfamiliar things, delicate things, that's still a massive hurdle.
Sure.
So Alex seems to be tackling that head-on, which kind of contrasts with other robots maybe focusing more on just walking around or lifting heavy stuff. Where do you see that nuanced manipulation being most impactful first?
Oh, I can immediately see logistics, handling all sorts of different packages. Or maybe delicate assembly tasks where parts aren't perfectly uniform. It opens up areas robots couldn't easily handle before.
Makes sense.
And if you want to talk about precision, you have to hear about Daxa Robotics' flexible hand.
Okay.
This thing sounds like an engineering marvel, each joint driven by multiple tendons for really robust control. And here's the kicker. Each hand uses an astonishing 108 motors.
108 in one hand.
Per hand, enabling 108 actively controlled degrees of freedom, plus what they call infinite passive DOE. They even showed it off on a new podcast, apparently. Clever marketing.
Wow, 108 motors, the sheer number there. That level of fine motor control, that intricate articulation, it could be genuinely revolutionary.
Okay.
You connect that to the bigger picture, it really suggests a future where robots can do tasks needing extreme precision, adaptability, delicate interactions that we thought only human hands could manage. Where do you think that kind of robotic touch could have the most profound impact? Surgery, handling fragile objects.
I think both of those are prime examples. Imagine surgical robots with just unprecedented finesse, or robots handling priceless, fragile artifacts in a museum or archaeological dig. It's a huge leap.
It really is.
Okay, so now let's bridge the gap. How is AI enabling these amazing physical robots to actually navigate and interact with our messy, complex world more intelligently? And importantly, safely.
This is where it gets really interesting, the hardware meeting the AI brain.
Right. Figure, for example, they've been working on robust walking for their humanoids. They're using something called the Helix walking controller. And here's the really surprising bit. This controller let their robot walk across different surfaces without using cameras to see what was ahead.
Walking blind, essentially.
Feels like it. That is kind of mind-bending. But practically, how does a robot know where to step without seeing? Is it all just like internal sensors and learned reflexes?
That's a great question, and it really highlights how sophisticated these control systems are becoming. A system like Helix probably relies heavily on advanced proprioception. That's the robot's internal sense of his own body, its limbs, its motion, combined with really fast dynamic balancing algorithms. It's more about internal models, rapid feedback loops. The robot essentially feels the terrain and adjusts instantly, rather than purely seeing it.
Ah, okay. Feeling versus seeing.
Yeah, and that's a massive leap in robustness. It makes robots far more capable in unpredictable places where cameras might fail or get dirty or the lighting is bad, real-world conditions.
That makes a lot more sense. Okay, then there's Field AI. They just raised a huge funding round, $405 million.
Wow, that's serious cash.
It is. And they introduced Field Foundation models. These are specifically designed, they say, to grapple with uncertainties and the physical constraints of the real world. Their whole aim is enabling safe robot behaviors when navigating in new environments. That funding level suggests the market really believes this is solvable and critical.
And that explicit focus on uncertainties and physical constraints, that's not just jargon, is it? That's the core challenge that's kept most advanced robots stuck in labs or highly controlled settings.
Sure, exactly.
So Field AI seems to be tackling that gap head-on, the gap between the lab and the real world, by emphasizing safe behaviors in new environments. What kind of wider robot adoption does that unlock, do you think, beyond factories?
Well, it really paves the way for robots in public spaces, maybe helping in homes, or even in disaster relief zones, places that are inherently unstructured, unpredictable. Safety is paramount there.
Absolutely.
And speaking of breakthroughs, there's a major collaboration between Boston Dynamics and the Toyota Research Institute. They debuted a large behavior models, or LBMs.
LBMs, okay.
These AI policies let their Atlas robot do complex, multi-step tasks, things like folding the legs on their Spot robot, tying ropes, even manipulating tires. But here's the really crucial part. The LBMs allowed Atlas to adapt to errors in real time.
Adapt to errors in real time. Okay, let's unpack that. LBMs are essentially these massive AI models trained on tons of data, learning complex action sequences. But critically, learning how to react when things don't go exactly as planned. That ability to do multi-step tasks and adapt to errors, that is a monumental step for robot autonomy.
It feels like it.
It moves robots beyond just running a pre-programmed sequence towards genuine problem-solving in dynamic situations. For you, what's the biggest difference there between a robot just following instructions and one that's truly problem-solving?
It feels like the difference between a tool and, well, a genuine collaborator, doesn't it? It means less need for constant human oversight, less need for perfectly predictable environments. The robot can actually figure things out on its own to some extent.
A huge step towards useful autonomy.
Definitely. And one more in this area. Stanford debuted their HED system, that's HEAD. It's an autonomous navigation and reaching system. What's really clever here is how it learns. It learns navigation, locomotion, reaching, directly from human motion and vision data.
Learning from us.
Yeah. So it allows humanoids to move around obstacles and touch an object if needed, essentially by mimicking how we do it.
That paradigm, learning directly from human motion and vision, that's powerful.
Yeah.
Instead of trying to program every single possible scenario, which is practically impossible, this approach lets robots kind of absorb our biological intelligence, our adaptability. It feels like a shortcut to common sense interaction, doesn't it?
It really does, like teaching by showing, rather than writing a massive, complex instruction manual.
Exactly.
Okay, finally, let's take a quick glimpse at how AI is tackling some highly specialized, really critical problems, stuff that might not hit your daily news feed but has a massive impact.
Beyond the usual consumer and industrial focus.
Right. IBM and NASA teamed up. They introduced Suria. It's an open source AI designed specifically to predict solar flares.
Predicting solar flares. Okay.
Yeah. This AI was trained on a huge data set, 9 years of high-res imagery from NASA's Solar Dynamics Observatory, the SDO. And the result? Suria predicts these solar outbursts faster than ever before, and it beats the existing benchmarks by a pretty solid 16%.
Wow. So applying AI to a cosmic problem, but one with very real-world impacts down here on Earth.
Exactly.
Solar flares can disrupt satellites, power grids, communications. So prediction is vital. It really underscores the versatility of AI, doesn't it? Applying machine learning way beyond the usual domains. What does this tell you about the potential reach of AI? Where else might we see it pop up?
It's just a powerful reminder, I think, that AI is becoming this incredible tool for understanding and mitigating risks across just an astonishing range of fields, even things literally out of this world.
Truly universal tool.
What a deep dive. We've covered so much ground here, from those agentic spreadsheets and free coding platforms changing how we interact with software, to humanoids teasing incredible dexterity, 108 motors in a hand, and robots walking across rough ground without even needing to see it.
And AI navigating those complex, uncertain real-world environments safely.
Right. And then topping it off with AI predicting solar flares to help protect the planet. The speed and just the sheer variety of these updates from just late August, it really highlights this exciting convergence. AI and robotics feeding off each other across so many diverse fields.
It's quite something to witness.
It really is a testament to ingenuity.
Indeed. And if you look at the broader implications, the common thread running through so many of these advancements is, undeniably, adaptability and autonomy. We're seeing AI and robots becoming far more capable of operating in these unstructured, unpredictable real-world settings, needing less direct human control, having more inherent intelligence.
That seems to be the direction of travel.
Which brings up, I think, an important closing thought for you, our listener. As these technologies get smarter, more capable, more integrated into, well, every facet of our world, what new ethical considerations or maybe societal impact should we be actively thinking about now? What should we be preparing for next? It's a future we are all shaping right now.